The United States is constructing the most impressive megaprojects yet in 2026, and they are shaping up to become record-breaking developments. From the most expensive railway in the nation's history to one of the biggest stadiums ever, these are America's projects under construction in 2026. In the background of Manhattan's constant motion, one of the most consequential US megaprojects still taking shape in 2026 is the 2nd Avenue Subway Phase 2, a northward expansion designed to permanently change transit access in East Harlem. Phase 2 extends the 2nd Avenue subway from its current northern terminus at 96th Street to 125th Street, adding 3 new stations at 106th Street, 116th Street, and 125th Street, with a critical connection to the existing Lexington Avenue line. The project's purpose is capacity relief. By drawing riders away from the chronically overcrowded Lexington Avenue corridor, it rebalances passenger loads across Manhattan's east side. By 2026, construction activity will be concentrated almost entirely underground. Tunnel boring for the main running tunnels is already complete, allowing work to focus on station cavern excavation, structural concrete placement, and the build-out of mezzanines, platforms, and emergency egress systems. At the surface level, utility relocation continues along 2nd Avenue and 125th Street, involving water mains, sewers, electrical infrastructure, and communications lines that must be fully reconfigured before permanent station entrances can be finished. Throughout 2026, crews are also advancing ventilation structures and ancillary facilities required for modern subway safety standards. These include fan plants, traction power substations, and cross passages between tunnels for emergency evacuation. Early stages of track bed preparation are expected to begin once structural shells reach sufficient completion, though rails, power systems, and signaling installations remain later phase work. San Diego International Airport stands as one of the most active aviation megaprojects under construction in the United States, with 2026 marking a critical transition year from heavy civil work to systems integration and operational readiness. The expansion centers on the new Terminal 1 program, a complete replacement of the airport's original terminal complex. This project consolidates outdated facilities into a modern, single-terminal structure designed to handle long-term passenger growth within one of the most spatially constrained airport footprints in the country. The new terminal increases capacity, improves seismic resilience, and reorganizes landside and airside operations to reduce congestion. During 2026, construction activity is focused on interior build-out, systems installation, and final structural completion. Major concrete and steel framing work is largely finished by this stage, allowing crews to advance mechanical, electrical, and plumbing systems throughout the terminal. Baggage handling systems, passenger screening infrastructure, and gate-level utilities are installed and tested in phases. Interior finishes, including concourses, hold rooms, and concession spaces, progress simultaneously across multiple levels. Airfield side work continues in parallel throughout 2026. This includes apron paving, jet bridge installation, and integration of aircraft servicing systems at new and reconfigured gates. Taxiway connections are refined to accommodate revised aircraft circulation patterns, while airfield lighting and navigational systems upgraded to align with the expanded terminal layout. Landside construction remains a defining feature of the 2026 schedule. Roadway realignments, curbside drop-off zones, and parking access routes are completed to support the new terminal's circulation plan. A new parking plaza and rental car facilities move closer to operational readiness, with traffic control systems and pedestrian connections tested under live conditions. The terminal is being delivered in multiple phases to allow continuous airport operations. In 2026, phased commissioning becomes a dominant activity, including fire life safety testing, security system certification, and coordination with airlines for gate activation. Workforce training and operational simulations are conducted inside completed areas ahead of public opening. Reconstruction along the Patapsco River has become one of the most consequential US infrastructure efforts of the decade, and by 2026, the Francis Scott Key Bridge replacement stands firmly among the largest megaprojects under construction in the United States. The project replaces the original steel arch bridge that once carried Interstate 695 across Baltimore Harbor, a critical freight and commuter link serving the Port of Baltimore and the broader Mid-Atlantic logistics network. The collapse of the original structure accelerated federal and state coordination, compressing planning timelines and moving the replacement into an unprecedented fast-track delivery process. By 2026, construction activity is concentrated on full superstructure erection and approach integration. Foundation work, including deep water drilled shafts and pier construction, is substantially complete by this stage, allowing crews to advance pier caps and begin assembling the primary bridge spans. Marine construction remains continuous throughout the year, with heavy lift cranes operating from barges to place steel and precast concrete elements in navigable waters without interrupting port traffic. During 2026, deck construction becomes a dominant activity. Crews install deck panels, post-tensioning systems, and drainage infrastructure, while simultaneously advancing structural steel erection across multiple spans. Wind bracing, redundancy elements, and vessel collision protection systems are integrated as part of a redesigned structure intended to exceed modern safety and resilient standards. Approach roadway construction also accelerates in 2026. Earthwork, retaining walls, and elevated approach viaducts are built to reconnect the new bridge with existing segments of I-695. Utility relocations, stormwater management systems, and intelligent transportation system conduits are installed concurrently to minimize future disruptions. Pavement base layers are placed late in the year as alignment geometry is finalized. The replacement bridge incorporates a higher vertical clearance and a wider navigational channel, responding directly to modern container ship dimensions. Seismic upgrades, enhanced fender systems, and reinforced piers are integral to the design, reflecting updated federal bridge standards and lessons learned from the original structure's failure. By late 2026, the project transitions from heavy structural work to systems installation and finishing. Barrier walls, lighting, signage foundations, and tolling or traffic monitoring infrastructure are installed in preparation for final paving and commissioning. Load testing and phased inspections are scheduled to follow structural completion. Long before the first kickoff, the new Commanders Stadium emerges in the mid-2020s as one of the most closely watched US mega projects projected to be under active construction in 2026, reshaping how large professional sports venues are delivered in dense metropolitan regions. The project replaces the team's aging suburban facility with a modern, urban integrated stadium complex designed to anchor broader mixed-use redevelopment. The stadium is planned as a next-generation NFL venue, emphasizing premium seating, expanded concourses, advanced digital infrastructure, and year-round usability rather than single-event operation. Its scale places it among the largest privately and publicly coordinated construction efforts in the Washington region. By 2026, construction activity is expected to be firmly in the vertical and enclosure phases. Site preparation and foundation work, including deep piles and mat foundations capable of supporting long-span roof systems, are largely complete by this point. Structural steel erection dominates the construction schedule throughout the year, forming the bowl geometry, upper concourses, and primary roof supports. Precast seating elements are installed in parallel to accelerate schedule and allow interior work to begin earlier. Throughout 2026, crews advance mechanical, electrical, and plumbing rough-ins across multiple tiers of the stadium. Power distribution systems, backup generation, and life safety infrastructure are embedded early due to the complexity of event operations. Large-scale audio-visual backbone systems, including control rooms and cable pathways, are integrated integrated during this stage rather than deferred to final fit-out. Exterior enclosure work intensifies during 2026. This includes facade panels, glazing systems, and weatherproofing necessary to transition construction from structural assembly to interior finishing. Roof installation progresses in segments, often using temporary supports and heavy lift cranes to place long-span trusses or tensile elements without disrupting the bowl below. Landside construction is also active during this period. Access roads, structured parking, transit interfaces, and pedestrian plazas are built concurrently to ensure the stadium functions as part of a larger district rather than an isolated venue. Utility corridors for water, power, and data are extended to support both the stadium and surrounding development parcels. At the eastern edge of St. Paul, one of the Midwest's most ambitious urban redevelopment megaprojects continues to take shape, with 2026 marking a sustained construction phase for the Heights, a former industrial site being transformed into a long-term mixed-use district. The Heights occupies the former Hillcrest Ford Assembly Plant site, a large brownfield parcel left vacant after automotive manufacturing ended. The redevelopment is structured as a multi-decade project rather than a single build, combining housing, employment space, light industrial uses, civic facilities, and new infrastructure into a walkable, transit-ready neighborhood. Its scale places it among the largest redevelopment efforts under construction in the United States during the 2026 timeframe. By 2026, construction activity is distributed across multiple fronts. Core infrastructure work continues, including roadway build-out, underground utilities, district-scale stormwater systems, and power distribution designed to support phased vertical development. Street grids, sidewalks, and bike infrastructure are actively being extended to unlock additional development parcels across the site. Vertical construction accelerates in 2026 with multiple residential and mixed-use buildings rising simultaneously. These include market-rate housing, affordable units, and workforce housing delivered in separate phases to maintain financial and construction flexibility. Structural framing, enclosure, and interior fit-out are underway on several blocks, allowing early residents to occupy completed buildings while others remain under construction. Employment-focused construction is also active in 2026. Flexible office, production, and research-oriented buildings are being built to attract technology, manufacturing adjacent, and institutional tenants. These structures emphasize adaptable floor plates, higher load capacities, and modern utility access, reflecting the site's shift from heavy manufacturing to contemporary job uses. Environmental remediation and sustainability measures remain a defining feature of the project during this period. Soil remediation, groundwater management, and long-term monitoring continue alongside construction. Buildings are designed to meet elevated energy standards with district energy concepts, green stormwater infrastructure, and reduced car dependency integrated into site planning rather than added later. Public realm construction expands in 2026. Parks, open spaces, and civic gathering areas are graded and landscaped as adjacent buildings reach completion. These spaces are delivered early to establish neighborhood identity before full build-out, reinforcing long-term livability goals. Across the Pacific Northwest, Portland International Airport represents one of the most technically complex U.S. aviation megaprojects under construction in 2026, defined by a full-scale reinvention of its terminal core while maintaining uninterrupted airport operations. The renovation centers on the complete replacement and expansion of the main terminal complex, including the ticketing hall, security screening areas, concessions, and international arrivals processing. Rather than incremental upgrades, the project restructures passenger circulation from curb to gate, addressing seismic risk, capacity constraints, and outdated building systems in one integrated program. By 2026, construction activity is concentrated on interior completion, systems integration, and phased commissioning. The primary roof structure, a long-span mass timber system, is fully erected by this stage, allowing interior spaces beneath it to transition into mechanical, electrical, and architectural fit-out. Crews advance HVAC distribution, fire protection, and electrical systems throughout the terminal core, coordinating installations around active passenger flows. Security checkpoint infrastructure is a major focus during 2026. New screening halls are built and activated in stages, incorporating expanded queuing capacity and reconfigured passenger paths. Baggage handling systems beneath the terminal are upgraded concurrently, with conveyor networks, screening equipment, and control systems tested during overnight construction windows to avoid operational disruptions. International arrivals facilities continue to advance through 2026, including customs processing areas, sterile corridors, and supporting building systems. These upgrades are timed carefully to align with airline schedules and federal inspection requirements, making phased turnover a critical element of the construction strategy. Airside and landside work remains active during this period. Gate hold rooms are renovated, utilities are modernized, and apron-adjacent systems are coordinated with terminal improvements. On the landside, curbside layouts, vertical circulation cores, and pedestrian connections are refined to match the reconfigured terminal interior. Sustainability and seismic resilience remain embedded throughout 2026 construction. Structural retrofits, base isolation elements, and energy-efficient building systems are finalized as part of the broader modernization effort. Material selections and system layouts reflect long-term operational efficiency rather than short-term capacity gains. The renovation is being delivered in carefully sequenced phases, with partial openings occurring before full completion. Major components are expected to open to passengers in the mid to late 2020s, with final construction and commissioning extending toward 2027. By the end of 2026, Portland International Airport has moved decisively from structural reconstruction into operational readiness. Stretching across the agricultural heart of California, the Central Valley segment of California high-speed rail remains one of the largest transportation megaprojects under construction in the United States, with 2026 representing a peak year for heavy civil and structural work. This segment forms the initial operating corridor of the statewide high-speed rail system, running between the cities of Merced, Fresno, and Bakersfield. It is designed to establish the first true high-speed rail spine in the country, built to international standards with fully grade-separated alignments, dedicated tracks, and electrified operations. By 2026, construction activity is concentrated on completing guideway structures and advancing rail systems installation. The majority of major viaducts, aerial structures, and embankments are structurally complete, allowing crews to focus on deck finishing, parapets, and track slab preparation. Ongoing work includes the completion of grade separations at roadways, canals, and freight rail crossings, a defining feature of the project's safety strategy. Throughout 2026, track installation accelerates along long continuous stretches of the alignment. Crews install precast concrete track slabs, continuously welded rail, and fastening systems designed for sustained operation at speeds exceeding 200 miles per hour. Overhead, catenary foundations and poles are erected in parallel, setting the stage for electrification work in subsequent phases. Station construction progresses during this period, particularly in Fresno, where structural shells, platforms, and access facilities move toward enclosure. Utility relocations, drainage systems, and access roads continue across rural segments, reflecting the complexity of threading new infrastructure through active farmland and irrigation networks. Environmental mitigation remains active in 2026. Wildlife crossings, water management features, and habitat restoration areas are built alongside the guideway, addressing long-term regulatory commitments. Noise barriers and visual screening elements are installed where the alignment approaches communities. Systems integration begins in limited segments during 2026. This includes early installation of signaling conduits, fiber optic communications, and power distribution infrastructure, even as civil work continues nearby. Testing remains limited, but preparatory groundwork expands significantly. Below Nashville's surface level growth, One of the most unconventional US megaprojects projected to be under construction in 2026 is the Music City Loop, a privately driven underground transportation system designed to relieve downtown congestion through grade-separated tunnels. The Music City Loop is planned as a network of narrow, electrically powered tunnel corridors connecting key destinations in Nashville's urban core, including the Convention District, major entertainment areas, and regional transit hubs. Unlike traditional rail megaprojects, the system relies on smaller diameter tunnels and point-to-point travel, reducing surface disruption while accelerating construction schedules. By 2026, construction activity is expected to focus primarily on tunneling and underground structural works. Tunnel boring operations dominate the year, with machines advancing beneath downtown streets and river-adjacent corridors. Excavated material handling, tunnel lining installation, and waterproofing systems are completed continuously behind the boring heads to stabilize the underground alignment. Station box construction is also active in 2026. These facilities are built as compact underground nodes rather than large caverns, requiring deep excavation, reinforced concrete shells, and vertical access shafts. Elevators, stairwells, and emergency egress structures are installed concurrently as station structures rise towards street level. Utility coordination remains a major task, with water, sewer, electrical, and telecommunications infrastructure rerouted to accommodate station footprints. Systems installation begins in selected tunnel segments during this period. Power distribution rails, communications conduits, ventilation ducting, and fire safety systems are installed as soon as tunnel sections are structurally complete. Unlike rail systems, track infrastructure is minimal, but roadway surfaces, guidance systems, and vehicle interface technology are integrated early to support testing. Surface-level construction in 2026 remains limited but targeted. Small footprint access points, station entrances, and ventilation structures are built to minimize disruption in Nashville's dense downtown environment. Traffic management and phased closures are used to maintain access to surrounding businesses and venues. Testing and commissioning activities are expected to begin in limited segments late in 2026, including vehicle trials, emergency response simulations, and systems reliability checks. These activities occur while tunneling continues elsewhere in the network, reflecting the project's modular delivery approach. Current planning concepts place initial operational segments opening in the late 2020s, with system expansion continuing in phases thereafter. Full network build-out extends beyond the initial opening years and remains dependent on performance, ridership demand, and future private investment. On the western edge of downtown Atlanta, Centennial Yards continues to evolve as one of the largest urban redevelopment megaprojects under construction in the United States, with 2026 marking a sustained period of vertical building and infrastructure expansion. Centennial Yards is a multi-phase redevelopment of a former rail yard and underutilized industrial land, positioned between major downtown attractions and Atlanta's core business districts. The project is structured as a long-term transformation rather than a single construction effort, integrating residential towers, office space, hotels, retail, entertainment venues, and large-scale public spaces over multiple decades. By 2026, construction activity is distributed across several active parcels. Foundational infrastructure, including new street grids, utilities, and stormwater systems, continues to expand to support later phases. Roadway construction and streetscape installation advance throughout the site, enabling pedestrian and vehicular circulation to align with surrounding neighborhoods. Vertical construction is a defining feature of the 2026 timeline. Multiple mid-rise and high-rise structures are actively rising during this period, with structural concrete placement, steel framing, and facade installation occurring simultaneously across different blocks. Residential and hotel components move through enclosure and interior fit-out stages, allowing phased occupancy rather than a single opening. Public realm development remains active in 2026. Large plazas, green spaces, and pedestrian corridors are graded landscaped, and connected to adjacent transit stations. These spaces are delivered early to establish district identity and support surrounding development density. Utility vaults, lighting systems, and underground service corridors are installed beneath these areas to accommodate future buildings. Transportation integration continues as a major construction effort during this period. Improvements to nearby highway ramps, surface streets, and transit connections are coordinated with city agencies to handle increased traffic demand. Structural elements supporting decks and podiums over former rail infrastructure remain under construction, requiring complex sequencing to maintain active rail operations below. Interior construction accelerates late in 2026. Mechanical, electrical, and plumbing systems are installed across multiple buildings, followed by interior partitions, life safety systems, and tenant-ready spaces. Phased commissioning allows certain buildings to open while others remain under construction. Centennial Yards is planned as a multi-decade development, with early phases expected to be completed in the late 2020s and additional towers and amenities extending well into the 2030s. Full build-out is not tied to a single completion date, reflecting market-driven sequencing and long-term investment strategies. Just south of the Mississippi River Gorge, Highland Bridge continues its transformation into one of the most significant mixed-use redevelopment mega projects under construction in the United States, with 2026 representing a mature but still highly active phase of build-out. Highland Bridge occupies the former Ford Motor Company Twin Cities Assembly Plant site, a 122-acre parcel redeveloped into a dense, transit-oriented district. The project is designed as a long-term neighborhood rather than a single development, integrating housing, employment space, retail, civic uses, and extensive public infrastructure. Its phased delivery places it squarely among US mega projects still under construction in 2026. By 2026, the project has moved well beyond site remediation and primary infrastructure, but construction activity remains substantial. Vertical construction continues across multiple remaining parcels, with residential buildings in various stages of framing, enclosure, and interior fit-out. These include a mix of market rate, affordable, and senior housing, reflecting the project's affordability and density requirements. Concrete podiums and wood frame upper levels are typical during this phase. Commercial and institutional construction is also active in 2026. Office, medical, and flexible employment buildings continue to rise along key corridors, with structural systems largely complete and mechanical, electrical, and plumbing systems advancing. Ground floor retail shells are built in parallel, timed to open as residential occupancy increases. Public infrastructure work remains ongoing. Streets, alleys, sidewalks, and utilities are extended to serve later development phases, even as earlier sections are already occupied. District energy infrastructure, stormwater management systems, and underground utilities require continuous expansion and optimization as additional buildings come online. Open space construction is a defining feature of the 2026 timeline. Parks, plazas, and green corridors are graded, landscaped, and equipped with lighting, seating, and drainage systems. These spaces are delivered incrementally to ensure that livability keeps pace with density, rather than lagging behind it. Transportation-related construction continues throughout 2026. This includes pedestrian and bicycle infrastructure, transit access improvements, and traffic calming features designed to integrate the district with surrounding neighborhoods. Final roadway surface treatments and streetscape elements are installed as heavy construction winds down on individual blocks. Highland Bridge does not have a single completion date. The majority of core development is expected to be completed by the late 2020s, with final parcels and refinements extending into the early 2030s. By 2026, however, the project has clearly transitioned into its later construction phases, with a functioning neighborhood already in place. Northwest of the Twin Cities, the Monticello data center campus stands as one of the most infrastructure-intensive US mega projects under construction in 2026, reflecting the accelerating demand for large-scale digital and cloud computing facilities. The Monticello campus is designed as a multi-building, hyperscale data center complex rather than a single structure. Its development model relies on phased expansion, allowing capacity to grow incrementally as computing demand increases. The campus includes multiple data halls, energy infrastructure, cooling systems, and extensive site-wide utilities, positioning it among the most capital-intensive construction programs in Minnesota during the mid-2020s. By 2026, construction activity is concentrated on both vertical expansion and systems-intensive fit-out. New data center buildings are rising alongside previously completed structures, with structural steel framing, precast concrete panels, and high-load floor systems installed to support dense server environments. Enclosure work progresses rapidly to allow climate-controlled interior construction to begin as early as possible. Inside the buildings, 2026 is dominated by mechanical and electrical installation. Crews install power distribution units, backup generators, uninterruptible power supply systems, and redundant electrical pathways designed to meet stringent uptime requirements. Cooling infrastructure, including chilled water systems, air handling units, and heat rejection equipment, is integrated simultaneously, requiring precise coordination due to spatial and operational constraints. Site-wide infrastructure construction remains active throughout 2026. This includes expanded electrical substations, underground duct banks, fiber conduit networks, and water systems capable of supporting both cooling and fire suppression. Roadways and security perimeters are extended to accommodate additional buildings, while staging areas are continuously reconfigured to support overlapping construction phases. Commissioning activity becomes a major focus during this period. Newly completed data halls undergo stage testing, including power load validation, cooling performance verification, and failover simulations. These processes occur while adjacent buildings remain under construction, requiring strict operational separation and safety controls. Environmental and efficiency measures continue to shape construction in 2026. Water usage optimization, energy-efficient cooling strategies, and waste heat management systems are implemented as part of long-term operational planning. Landscaping and stormwater management features are installed in parallel to meet regulatory and sustainability requirements. Rather than a single headline project, Minneapolis-St. Paul International Airport enters 2026 as a layered construction zone with multiple concurrent megaprojects collectively reshaping one of the Upper Midwest's most important aviation hubs. The airport's capital program is organized around phased modernization rather than wholesale replacement, allowing continuous operations while major systems are rebuilt. By 2026, MSP is firmly in an active construction cycle, addressing terminal capacity, airfield reliability, ground transportation, and aging utility infrastructure, placing it among US megaprojects still under construction during that year. At Terminal 1, construction in 2026 is centered on concourse and systems renewal. Interior renovations continue across gate areas, including structural rehabilitation, new passenger hold rooms, and expanded concessions footprints. Mechanical, electrical, and plumbing systems are replaced or upgraded behind finished spaces, requiring sequential closures and reopenings rather than full shutdowns. Baggage handling system upgrades progress below the concourses, with new screening equipment, conveyor lines, and control systems installed in phases to maintain security throughput. Airfield construction remains significant in 2026. Runway and taxiway rehabilitation projects advance throughout the year, involving pavement replacement, drainage upgrades, and lighting system modernization. These projects are tightly sequenced around seasonal weather and flight schedules, often shifting work between nighttime and daytime windows to maintain capacity at one of the nation's busiest airports. Landside construction is also prominent during this period. Parking and ground transportation facilities undergo continued redevelopment, including structural repairs, technology upgrades, and circulation improvements. Roadway realignments and curbside modifications are implemented to support evolving passenger flows and future terminal access patterns. Utility and energy infrastructure upgrades continue beneath active facilities in 2026. Electrical distribution systems, steam, and chilled water networks, and communications backbones are replaced or expanded to support future terminal projects. These works are largely invisible to passengers, but represent some of the most technically complex construction on site. Terminal 2 construction activity in 2026 focuses on targeted expansions and interior modernization, gate reconfigurations, boarding bridge replacements, and passenger processing upgrades are implemented incrementally, allowing low-cost carrier operations to continue without large-scale displacement. MSP's current modernization cycle extends beyond 2026, with major elements scheduled to reach completion in the late 2020s. Individual projects finish at different times, but the overall capital program is structured to continue well into the next decade as demand and regulatory requirements evolve. Spanning multiple counties and decades of delivery, the Sound Transit 3 expansion remains one of the most extensive transit megaprojects under construction in the United States, with 2026 positioned as a year of simultaneous tunneling, elevated guideway construction, and systems installation across the Seattle region. Sound Transit 3, commonly referred to as ST3, is a voter-approved program to dramatically expand light rail, commuter rail, and bus rapid transit infrastructure throughout the Puget Sound area. The program includes new light rail corridors extending north, south, east, and west of Seattle, alongside infill stations and operations facilities, making it a distributed megaproject rather than a single construction site. By 2026, multiple ST3 light rail segments are in active construction. Tunnel boring operations are underway on urban corridors, where dense development and waterways limit surface construction options. These tunneling efforts involve deep launch shafts, continuous lining installation, and groundwater control in complex glacial soils. In suburban segments, elevated guideways and retained fill structures dominate construction activity, with precast segment erection progressing along highway and arterial corridors. Station construction is a defining focus during 2026. Underground stations advance through cavern excavation, structural lining, and platform slab installation, while elevated and at-grade stations move through structural framing, enclosure, and vertical circulation installation. Station finishes remain limited at this stage, with emphasis placed on structural completion and systems readiness. Systems work expands significantly in 2026. Track installation progresses on completed guideway segments, including direct fixation track and special track work at crossovers. Overhead catenary poles and foundations are installed, setting up future electrification. Communications and signaling conduits are embedded early, reflecting the complexity of integrating new lines into an operating network. Along Georgia's coast, the Port of Savannah continues its transformation as one of the largest freight infrastructure megaprojects under construction in the United States, with 2026 marking an advanced phase of terminal expansion and capacity optimization. The expansion program at the Port of Savannah is centered on increasing container throughput to accommodate larger vessels and sustained growth in East Coast trade volumes. Rather than a single build, the project consists of layered terminal improvements, yard expansions, berth enhancements, and landside connectivity upgrades delivered in overlapping phases. Its scale places it among the most consequential logistics projects active in the US during the mid-2020s. By 2026, construction activity is focused on terminal yard reconfiguration and equipment integration. Additional container stacks are built with reinforced pavement systems capable of supporting higher density storage and automated handling equipment. Rail-mounted gantry crane infrastructure is installed or expanded, including foundations, power systems, and control interfaces to improve yard efficiency. Berth and dock work remains active during this period. Wharf strengthening, fender system upgrades, and crane rail extensions are carried out to support the next generation of ultra-large container vessels. Maintenance dredging and channel optimization continue to preserve authorized depths and improve tidal access, ensuring consistent navigability for fully loaded ships. Intermodal construction is a defining component of the 2026 schedule. On-dock rail capacity is expanded through new track segments, switches, and staging areas, allowing a higher share of containers to move directly from ship to train. Signal systems, grade crossings, and rail yard support facilities are installed concurrently to improve reliability and throughput. Landside infrastructure upgrades continue throughout 2026. Gate complexes are expanded with additional lanes, inspection technology, and automated processing systems to reduce truck dwell times. Roadway improvements connect terminal entrances to regional freight corridors, easing congestion beyond port boundaries. Electrical and energy infrastructure work intensifies during this stage. Substations, power distribution networks, and backup systems upgraded to support expanded crane fleets and future automation. These systems are installed while maintaining continuous port operations, requiring detailed sequencing and redundancy planning. The Port of Savannah expansion program extends beyond 2026, with major capacity milestones targeted for the late 2020s. Individual terminal projects reach completion at different times, but the overall effort is structured to add incremental capacity year over year, rather than waiting for a single final opening. Off the Atlantic coast of the Mid-Atlantic, coastal Virginia offshore wind stands as the largest offshore wind energy project under construction in the United States, with 2026 marking a decisive transition from offshore installation to commissioning and grid integration. The project consists of a large-scale array of wind turbines installed in federal waters off Virginia Beach, supported by offshore substations, export cables, and onshore transmission infrastructure. Designed to deliver utility-scale renewable energy directly into the regional power grid, the project represents a foundational shift in how large energy megaprojects are built along the US East Coast. By 2026, offshore construction activity is largely focused on turbine installation completion and system commissioning. The majority of monopile or jacket foundations are already installed by this stage, allowing crews to concentrate on erecting turbine towers, nacelles, and blades during favorable weather windows. Specialized installation vessels operate continuously, coordinating lift sequences and electrical hookups across the wind farm footprint. Subsea cable work continues throughout 2026. Inter-array cables linking turbines to offshore substations are installed, buried, and tested, while export cables connecting the wind farm to shore undergo final protection and commissioning. Cable landfalls and transition joints are completed earlier, allowing onshore systems to be energized as offshore components come online. Offshore substations remain active construction sites during this period. Electrical equipment installation, commissioning of transformers, and integration of control systems are carried out to enable high voltage transmission back to land. These facilities are critical for aggregating power from dozens of turbines and stabilizing output before grid injection. Running through the center of North Texas, the Interstate 30 reconstruction in Dallas stands as one of the most disruptive and consequential highway megaprojects under construction in the United States, with 2026 positioned as a peak year for large-scale roadway and structural work. The project focuses on rebuilding and reconfiguring Interstate 30 through East Dallas and adjacent neighborhoods, replacing aging freeway infrastructure originally built in the mid-20th century. The reconstruction is designed to address congestion, safety deficiencies, flood risk, and outdated interchange geometry while modernizing one of the region's most heavily traveled freight and commuter corridors. By 2026, construction activity is fully underway across multiple segments of the corridor. Demolition of existing elevated structures and retaining walls is largely complete in early phases, allowing crews to advance new mainline freeway construction. This includes excavation for lowered roadway sections, placement of drainage systems, and construction of new bridge structures carrying local streets over the interstate. Extensive earthwork dominates the schedule as the corridor profile is reshaped. Bridge construction is a defining feature of the 2026 timeline. Numerous overpasses and interchanges are rebuilt simultaneously, involving deep foundations, concrete pier construction, and long-span girders. These structures are designed to accommodate wider lanes, shoulders, and future traffic demands. Temporary traffic shifts and detours remain in place throughout the year to maintain regional mobility. Pavement construction accelerates during 2026. Crews place base layers, reinforced concrete pavement, and shoulders along newly completed sections of the main line. Drainage improvements, including stormwater detention and flood mitigation systems, are installed to address long-standing flooding issues along the corridor. Utility relocation continues as a parallel effort throughout the year. Water, sewer, gas, and telecommunications lines are rerouted or replaced to clear conflicts with the new roadway geometry. These activities are coordinated block by block to prevent service disruptions in surrounding neighborhoods. Urban design and mitigation elements also advance in 2026. Noise walls, landscaping zones, and pedestrian connections are constructed alongside the freeway to reduce community impacts. Space for future deck caps and potential redevelopment is preserved in the corridor's final configuration, reflecting a shift toward more integrated highway design. Beneath one of the busiest convention districts in the United States, the Las Vegas Convention Center loop expansion continues as an unconventional transportation megaproject under construction in 2026, characterized by rapid tunneling and phased system activation rather than traditional transit build-out. The expansion builds upon the initial underground loop serving the Las Vegas Convention Center, extending the tunnel network to additional halls, adjacent resorts, and regional destinations. The system is designed around small diameter tunnels carrying electric vehicles, allowing point-to-point travel without surface interference. Its delivery model emphasizes speed of construction and incremental openings. By 2026, construction activity is dominated by ongoing tunnel excavation and station development. Tunnel boring machines advance beneath active roadways and developed parcels, with continuous installation of precast concrete linings and waterproofing systems. Spoil handling and shaft logistics are managed within tight urban constraints, enabling multiple tunneling fronts to operate simultaneously. Station construction is a major focus during this period. Compact underground stations are built using cut and cover or mined excavation methods depending on location. Reinforced concrete structures, platform areas, and vehicle turnaround zones are formed while surface level disruptions are minimized. Vertical access elements, including elevators, stairs, and emergency egress shafts, are installed early to support later commissioning. Systems installation expands throughout 2026. Power distribution, communications infrastructure, fire life safety systems, and ventilation equipment are installed as tunnel segments reach structural completion. Roadway surfacing within tunnels and guidance systems for autonomous or semi-autonomous vehicles are implemented to support early testing. Surface construction remains targeted and limited in footprint. Station entrances, ventilation structures, and electrical rooms are built at street level, often integrated into existing developments. Traffic management and phased closures are used to maintain access in a tourism-heavy environment. Testing and commissioning activities become more prominent late in 2026. Vehicle operations are tested in newly completed segments, emergency response procedures are validated, and system reliability trials are conducted while tunneling continues elsewhere in the network. This overlapping approach allows partial openings without waiting for full system completion. Cutting across the Mojave Desert between Southern California and Las Vegas, Brightline West stands as one of the most prominent intercity rail megaprojects under construction in the United States, with 2026 marking a decisive phase of heavy civil and systems work. Brightline West is a privately led, high-speed rail corridor designed to connect the Los Angeles region with Las Vegas using a fully grade-separated alignment largely within the Interstate 15 right-of-way. The project is structured to deliver frequent, electrified passenger service at speeds far exceeding conventional US rail, targeting both leisure and business travel markets. By 2026, construction activity is concentrated across multiple desert segments simultaneously. Guideway construction dominates the schedule, including embankment formation, retained fill structures, and elevated viaducts required to maintain straight, high-speed geometry through complex terrain. Crews place structural concrete, erect precast segments, and complete bridge spans over washes, local roads, and freight rail crossings. Track infrastructure work accelerates during this period. Slab track installation advances on completed guideway sections, followed by continuously welded rail placement and fastening systems designed for sustained high-speed operation. Turnouts and special track work are installed at maintenance access points and terminal approaches. Systems installation expands significantly in 2026. Overhead catenary poles and foundations are erected along long stretches of the corridor, setting up future electrification. Signal and train control conduits are installed early, reflecting the project's reliance on advanced train control technology rather than legacy signaling. Fiber optic communications and power distribution networks are embedded alongside the alignment. Station construction remains active during this phase. The Las Vegas terminal structure advances through structural framing and enclosure, while California side facilities progress through foundation and superstructure work. These stations are designed as large intermodal hubs, integrating parking, passenger processing, and future transit connections. Environmental and desert-specific construction challenges shape 2026 work. Drainage structures, erosion control features, and wildlife crossings are built alongside the guideway to manage flash flooding and regulatory commitments. Heat-resistant materials and construction sequencing are used to maintain productivity in extreme conditions. Brightline West targets initial passenger service before the end of the decade, with current schedules generally pointing toward a late 2020s opening. Full systems testing, electrification, and commissioning are expected to follow major construction completion.